In group activity 3, we're focused on chapters 8 and 9. In particular, we're focusing on association claims, which are made with correlational data. As an example of a correlational or association research, I'm using a study published in 2017 in which the authors surveyed or measured different things from 56 adoptive parents in Italy. There's a range of measurements these authors collected, including parenting stress, the age of the child at adoption, emotional and behavioral difficulties, the parent's own well-being, as well as the relationship between the parents. If you notice, none of these measures can be manipulated. I do not have experimental control over the depressive symptoms of the parents, or the parents' well-being, or the age or emotional difficulties of a child. That's why this is an association claim. I can measure all of these things. I cannot manipulate them, be it for ethical or for obvious reasons that it's hard to assign people randomly to whether they're depressed or not. When we make correlational claims, we're going to use a Pearson's R correlation. And if you recall, those numbers range from a -1 up to a +1. The number in front indicates the directionality of the measures. In other words, a negative number means as one measure goes up, another measure goes down. In a positive claim, two measures move up or down in unison. The closer I am to 1 on either end of this spectrum, the more I can say about how closely tied or associated these two numbers are. The closer to 0, the less there is a chance that there's actually an association between two measures. So what I can do in this study is essentially look at all these different measures and pair them up and see how they relate to each other or how they're associated with each other. And that gives me a series of what we call bivariate correlations, once again, defined by our R value, but also by a p-value. And the p-value is the probability that those numbers could have happened just by chance. In a way, the p-value reflects whether my study is likely to reflect the real world or not. So the p-value that is small indicates those numbers couldn't have happened probably just by chance, and therefore they're likely to reflect the reality of the world. So a p-value of less than 0.05 indicates there's a 5% chance those numbers could have happened just by chance, 95% probability that those numbers mean something, that there's an actual correlation. When I have a p-value of 0.01, that's a 1% chance those numbers could have happened just randomly based on my sample. That means there's a 99% chance that those numbers reflect reality, that there's a real relationship between those numbers. And so what we do as we present this information is we pair up all the different measures and we present an R value in conjunction with a p-value. What I have at the bottom of this is a table that's reproduced from the PDF of this research article. The PDF is available on Canvas if you'd like to see the original table. I've simplified it a little bit, but in general what's happening is each of the measures that we're interested in have their own row. So the parenting stress as measured by mom, that's MP. Parenting stress as presented by dad, that's FP. In other words, that's the father's self-rating of his stress and the mother's self-rating of her stress. We also have information like the age of adoption, the mom's rating of her depression, the mom's rating of the tenderness of their relationship, indicated by tenderness MP. Now, each of these rows has a number associated with them. And in order to simplify everything, what we then do is we move those numbers across on the columns as well. So this fourth column represents the EB, or behavioral difficulties of the child, as measured by the mom's self-report, whereas column 5 is the parental depression as measured by mom. And then what we do is in each cell, where the rows and the columns coincide, we look at the R value and whether there's an asterisk indicating that the P value is significant. And so, for example, here we have row 2, parenting stress rated by dad, and its relationship to column 1, which is the parenting stress as measured by mom. In other words, these two measures, how strongly do they associate? Parenting stress by mom, parenting stress by dad. And here we have a value of 0.45. It's 0.47. It's a positive relationship, and the asterisks indicate that it's likely to reflect a real world relationship, that those numbers couldn't have happened by chance, or at least at a 0.00 at asterisks, with 2 asterisks, it's a 99% chance that those numbers reflect reality. And as we move over the columns, you can see the same thing happening. So here's column 10, and that reflects, 6, 7, 8, 9, 10. That's parental depression as rated by dad. And as we follow that column down, we can see the relationship of the ratings by dad of the tenderness of the relationship, once again, to his own ratings of depression, the sexuality of the parental depression or relationship. In other words, once again, where a row and a column bisect, we are giving an R value that indicates that bivariate correlation between two numbers. So you might ask yourself, well, why are some cells got dashes? Well, if you notice, that's where the same measure intersects itself. So column 6 represents the tenderness of the relationship as indicated by mom. Row 6 is the tenderness of the relationship as indicated by mom. In other words, a measure that correlates with itself is always a 1, and it's meaningless because a bivariate correlation is supposed to be about 2 different measures. And so in science, we just put dashes in those cells. Why is the top side of this triangle or this table triangle blank? Well, because once again, each column and row intersects with itself twice. Here we have column 10 intersecting with row 11, but row 11 or column 11 also intersects with row 10, and that cell's going to be blank because why present each number twice? This group activity asks several questions from your ability to look and read that table, but this study also does one step further, and it does a multiple regression, in particular focusing on chapter 9 material. In a multiple regression, what we're trying to do is take predictor variables and determine if we can use them to essentially talk about outcome, or sometimes referred to as criterion variables. In other words, this is an association claim. However, we as researchers have the ability to pretty much predict that certain variables are more likely to be the cause of other variables changing. In other words, we're going to hypothesize that there's a little bit of a causal relationship here. And in particular, we're going to say that we're most interested in things like parenting stress. Can we take certain variables that are predictors and see if they actually predict the levels of parenting stress? So we're assuming a directionality here. We're hypothesizing a directionality. We can't actually test it because, once again, I can't manipulate any of these measures. And so when I can't manipulate any measures, but I want to, in some ways, map out this type of relationship, I'm going to use a multiple regression. Each multiple regression can only evaluate one outcome or criterion variable. So if I'm interested in parenting stress, and that parenting stress has 2 parents, mom and dad, I have to conduct 2 different multiple regressions. When I conduct 2 different multiple regressions, I'm going to throw my predictor variables in there. And for example, here we have The multiple regression results, once again, from the paper for mother's parenting stress. Once again, that's our criterion or outcome variable. And I'm going to throw in the predictors or measures that I think are most likely to be able to predict mom's parenting stress. Why am I doing this? Because I want to determine what factors, what measures are best at predicting parenting stress, because then I could perhaps go in and help mom. I could perhaps reduce her stress by changing or adapt or essentially treating those predictors. So in this analysis in the top, we've got children's age at age of adoption, children's emotional behavioral difficulties as rated by mom, her depression as rated by mom, how much she quarrels in her relationship with dad, once again rated by mom, tenderness and sexuality as rated by dad. And if you notice, once again, our beta weight is very similar to an R value. It runs from a -1 to a +1. And once again, we want to focus on our p-values. We want to focus on those p-values that are p less than 0.05. It means that that's a strong relationship that's likely to reflect the reality of the world and not just have happened by chance. In this top part of this figure, you can see there are 2 p-values that reach a less than 0.05 value. And so according to this multiple regression, child's age at age of adoption and children's emotional behavioral difficulties as rated by mom are the 2 best predictors at being able to determine mom's parenting stress. I leave you to try to evaluate the father's parenting stress multiple regression. Once again, we're going to put in lots of predictors, and we're trying to predict the outcome, which is dad's parenting stress.